This video is going to have a look at homologous series. By the end of the video you'll know what a homologous series is and the different examples that you need to know for the exam. The definition of a homologous series is a group of compounds with the same general formula. You will have come across these in year 10 and you'll come across them again this year in a little bit more detail. They all have similar properties to each other, although the physical properties such as boiling points and melting points will change as the chain length becomes larger. So what do you need to know? You need to know the names, you need to know the formulas, and you need to know the structures of the four main homologous series which I'm about to go through with you. The first one is alkanes. Now this should be a recap from what you did in year 10. So you've got your first one here, which is methane, which has got 1 carbon, 4 hydrogens. Second one here, which is ethane, 2 carbons, 6 hydrogens, propane and butane. Now the general formula for this is CnH2n plus 2. So here I've got 1 carbon, I've doubled it to make 2 and added 2 to make 4. That tells me how many hydrogens I've got. 2 carbons times 2 plus 2 is 6, 6 hydrogens, and so on. Okay, so you'll be expected to be able to draw these structures as well as name them and give the chemical formula. The next one that you need to know are alkenes. Now you only need to know 3 of these, which is ethene, propene and butene. The reason for that is you can't have methane because there's no C-C double bond. Now the general formula for this is CnH2n. So nice and simply, you take the number of carbons, you double it, you've got the number of hydrogens. So that leaves you with C2H4, C4H8 and C3H6. The third one you need to know is the alcohols, which you should have seen in the previous video if you've been looking at that section. So it's exactly the same way as you draw your alkanes, except for in the end you have one OH group. And obviously alcohols can have more than one OH group. For what you need to know though, it's just one. Okay, now the general formula for this is CnH2n plus 1 OH. Naming, it's just the same name as the alkane, but with ol on the end. Methanol, ethanol, propanol, butanol. And there you have the structures. So C3OH for methanol, C2H5 for ethanol, C3H7 for propanol, and C4H9OH for butanol. Obviously remembering to add the OH on the end for each bit. And the final one you need to know, which you won't come across yet, is carboxylic acids. Now all carboxylic acids have this COOH group on the end. And that's what makes them apart from your alcohols and everything else. If you want to learn more about that, look at the carboxylic acid video in the next section. The general formula for a carboxylic acid is CnH2n plus 1 COOH. Now, the way that you work this out is slightly different here. If we were to have a look at methanoic acid, which is this one here, you would normally think it's got 1 carbon, which obviously it does, but that doesn't come into this formula here, because that's already part of that there. So we say, for methanoic acid, N equals 0. So it's 0 N's, therefore we've got 0 hydrogens plus 1 is 1, and then our COOH group. So it becomes HCOOH, which is methanoic acid. It then follows a similar format. So this one here, you've got 1 carbon, so it's 1 times 2 plus 1 is 3, COOH, 2 times 2 is 4 plus 1 is 5, and so on. So you get this. So ethanoic acid becomes CH3COOH, propanoic becomes C2H5COOH, butanoic becomes C3H7COOH, and so on. Okay? Again, the key thing here is that you take the start, which is similar, so instead of ethane, it's ethanoic acid, methanoic acid, butanoic acid, and so on.